Welcome to the Rich Report, a podcast with news and information on the world of cloud computing. Today, my guest is from NCP Engineering. We have the CTO of the company, Rainer Enders. Hello, Rainer. Welcome to the show today.
Hello, Rich. Well, thank you very much.
Thanks for coming on. I've been using different VPN solutions throughout my career, but this one intrigued me. So I was wondering if you could tell us more about it today. What do you guys do?
Yeah, sure. Thank you very much for having me here. I'm going to talk a little bit today about secure remote access. I will introduce you a little bit to NCP Engineering, talk about our products and a little bit about the technology behind the products. On slide number 2, NCP brings to the table over 25 years of remote access expertise. The company has 2 global headquarters, one in Germany and one in the United States in Northern California. We started in 1986 as the specialist for remote access software development. NCP simplifies secure remote access, effectively delivering on the vision of providing secure and remote network access from any location over any type of network using any type of device with high security and scalability, all based on open standards and protocols. What we think we do best, our managed software-based hybrid IPsec SSL VPN approach delivers scale and ease of use in one simple solution. We typically eliminate complexity for both users and administrators, which ultimately results in a reduced number of help desk calls and also from a user's perspective in a better end-user experience when using VPN. Our seamless integration into existing VPN network infrastructures actually delivers fast rollout and high efficiency. And with our managed approach, we can deliver automated change management. We also offer flexible implementation of customer requirements, and that's ultimately what makes us strong, the continuous feedback and input from our customers. Next slide, I'd like to talk a little bit about kind of a brief historic overview of VPN technologies. So I think it is fair to state that the most prevalent VPN technologies in use today are probably IPsec and SSL. Of course, IPsec is sort of the incumbent VPN technology, right? And it has long been criticized for some shortcomings and flaws. And probably the major one that people are always citing is that this IPsec VPN client that must be installed on the access device, and which typically requires administrative privileges to be installed and operational. And so the assessment here from users was that, well, with IPsec, the configuration expenditure is probably a little bit too high. So users eventually wanted an easy solution, right? So SSL VPN started out with the claim of being, easy and clientless, and I just put clientless in quotes here. As you see, we of course know that SSL VPN is not really clientless, so I actually prefer the terminology lightweight. So this lightweight SSL VPN approach, of course, only supported web-based applications initially, and that really wasn't sufficient, and users demanded more functionality. So SSL implemented the SSL VPN thin client, which could be downloaded on the fly, but it only supported applications with static ports. So, of course, that really wasn't enough either. And customers eventually required more functionality. So SSL VPN implemented the SSL VPN Fat client, which then again supported full network access, just similar to the case, what we had with IPsec. And of course, that client also requires now administrative rights and privileges. And so we are kind of the loop is closes itself there. We kind of back to square zero where we all started. So NCP says, let's just break through this vicious cycle and just use the existing robust technology and just fix the implementation issues. Just focus on those and just get this right. And this is really what we call our next generation network access technology, which delivers full network access, an easy installation, easy service, and really a comprehensive solution. I'd like to briefly talk about typical pains in remote access projects. Today's remote access projects typically involve different stakeholders at various levels in the company. So for one, there, of course, there's the user, right? And from the user perspective, VPN is typically kind of this remote dial-up procedure. It's a little bit too complex. Often, it's too slow. It frequently breaks down, and more often than not, it's just not flexible enough, right? So very often they tend to just grab the telephone, which of course kind of defeats the purpose. Then there's the person responsible for IT, and the IT manager obviously is confined within the constraints what the product technology and the products offer, right? So he can only really deliver so much. And of course, we know from a vendor's perspective, well, products just work as designed, right? I mean, we have heard that before. And then there is the network administrator. And network administrators, still today spend a lot of time on manual configuration and manual tasks. And of course, that is particularly in a remote access technologies that is very detrimental to large-scale rollouts. Then there is a person normally for that is responsible for IT security, right? And that person, of course, sees all these mobile devices floating out there in unknown and hostile networks. And, just in order to contain security, that person is pretty much interested to impose high restrictions on VPN use. And similarly at the top level, right, there's the executives who see the skyrocketing costs, for all these various components of remote access. And just for that reason, they really are interested to impose high restriction in the number of users for VPN, which of course all is somewhat unfortunate. So NCP really understands all these concerns very well and really can address these concerns and issues and really ultimately cure all these remote access pains with our solution. So the next slide just gives a little bit of an overview, kind of a context of the problem space, right? I mean, secure remote access really has become mission critical. I mean, as we all know, it's not just enterprise networks connecting to the internet. It's increasingly users working remotely from home, telework, road warriors working from hotspots, internet cafes, all those mobile devices, right? Various mobile devices of various shapes and forms and platforms that are floating out there, partially company-owned, partially employee-owned. Then, of course, cloud resources that enterprises increasingly utilize, right? Then there are all these different business relationships, of course, that require secure communication. Your suppliers, vendors, partners, outsourcing, offshoring, right? You name it. There are branch offices, of course, that companies have. And then there are new types of devices and networks that are joining the internet, such as smart home and industrial control systems and so forth. So the problem is not going to go away. So we really need scalable and secure and manageable security solutions here. So next slide, I like to talk a little bit about the specific security issue of VPN, right? So the three main pillars of VPN security are confidentiality, integrity, and authenticity. I mean, all the three are critical and vitally important, right? If one of them is broken, the whole security model is broken. So let's take a brief look. How do the most prevalent VPN technologies, SSL and IPsec, really measure up on those? Well, SSL security unfortunately has some serious flaws. The confidentiality in SSL really hinges on TLS, which unfortunately has many weaknesses. Although the newest version of TLS, version 1.2, was released quite a while ago, most servers and browsers actually only implement the older versions, TLS 1.0 and 1.1. There are actually many browsers still out there that just default to TLS 1.0, which is really the weakest TLS version, and many browsers don't even support the latest TLS versions. TLS ultimately suffers from things such as weak ciphers, browser exploits, weak random numbers for keys, and numerous implementation issues such as sensitive data is revealed in URLs, or use of the secure cookie flag, or mixing of TLS and non-TLS traffic. Then authenticity. Authenticity hinges on X.509 certificates. Now, X.509 certificates and certificate authorities cannot generally be trusted. I mean, there are unfortunately still many CAs that will sign almost anything. The problem here is that there are just too many certificate authorities out there today, too many trusted parties. The SSL Observatory regularly scans the open SSL ports and regularly detects hundreds of problems, such as weak certificates, broken keys. Some of them actually have perfectly valid signatures. Many violations of extended validation rules. I mean, the concept of extended validation certificates was implemented and released, but unfortunately, EV certificates are not really in wide use today. Then there is the unfortunate notion of domain-validated certificates. And then finally, the way how certificates are used for authentication as one-way certificates, which of course the real PKI implementation would be in a two-way certificates, right? Because the true vision of the PKI world, of course, is that both parties, client and server, present a publicly keyed certificate and prove knowledge and possession of the concerning private key, right? And then last but not least, there's the myth of clientless SSL, which of course we know is a myth, because even in the lightweight approach, you still need the web browser. There's always the web browser involved in any SSL VPN connection, and we do know of many browser exploits, unfortunately. And on the other hand, IPsec security, IPsec is really a set of open and strong security protocols standardized by the IETF. IPsec offers data-origin authentication, data integrity, data confidentiality, and also automated management of cryptographic keys and security associations via the IKE Internet Key Exchange protocols. IPsec specifies tunnel and transport modes for security, and it's integral part of IPv6. Actually, IPsec has been mandated for security within IPv6. So, if IPv6 is widely adopted and rolled out, you actually get IPsec with it for free, right? So next, I would like to go over the top kind of myths in that surround IPsec, and unfortunately, this is something that has been in people's mind historically for a long time, and still seems to be floating out there that this is still true. However, the implementation issues in IPsec have long been addressed. So I think it may be about time to maybe clean up a little bit these myths. So IPsec myth number one: IPsec is too difficult to use. NCP says, no, it's not. NCP has implemented in the VPN client an easy-to-use one-click solution. And what that really does is it integrates all these different software pieces and components and user interfaces that are required for a VPN connection, such as dialer, Wi-Fi registration, VPN client, client firewall, into one client interface and in one client software. So you have one IPsec VPN client that integrates all the functionality, and just with a few operations and with a one-click connect, you can actually operate all these components under the hood. In a seamless roaming scenario, of course, mobile devices tend to connect to all these different networks, and users occasionally or all the time actually have to figure out what network transport I'm actually having available, and how do I need to connect. And the NCP VPN client really resolves all this guesswork and always connects the VPN over the best available transport media. And likewise, in a roaming scenario, of course, mobile devices tend to switch between networks, right? For example, from Wi-Fi to mobile broadband and vice versa. And the NCP client will maintain the network connection across these different networks, if these roaming events occur. I mean, traditionally, of course, the connection would break down. User has to reestablish the connection. Not true anymore with the NCP IPsec VPN client. And the client even maintains the connection when the transport goes away, and actually maintains a virtual connection until the network transport resumes, and then will automatically resume that tunnel connection. So it's totally seamless from a user experience. IPsec myth number two: IPsec has many interoperability problems. NCP says, no, it has not. As a matter of fact, the NCP VPN client operates against all IPsec compliant VPN gateways from major system vendors such as Juniper, WatchGuard, Cisco, SonicWall, and so forth. And likewise, on the gateway side, the NCP VPN server gateway allows connectivity from all IPsec compliant third-party VPN clients, including the supposedly closed-end platforms, right, such as iOS and BlackBerry. Our large list of OEM partners on the IPsec VPN client really speaks to that, to that fact. Next slide. Likewise, on the gateway side, NCP provides our customers with that broad range of client platforms that are really required for a successful remote access project. Mobile broadband, of course, is an important transport medium for for mobile devices. More often than not, I mean, most clients will connect via broadband networks, and NCP integrates all the most relevant wireless broadband cards and broadband adapters within the software. So users don't need to install additional software or additional communication interfaces that they have to deal with. Myth number 3, IPsec is difficult to scale. NCP says, no, it is not. NCP has implemented a variety of scalability options in the server platform, such as the failsafe server, or slide number 19, load balancing, and slide number 20, VRRP for co-located servers. Slide number 21, of course, cloud service providers really require scalability of VPN services without any major limitations. IPsec myth number 4. IPsec is difficult to manage. NCP says, no, it's not. Next slide. Just like on the client side, on the management front, of course, network administrators have to deal with many different backends when it comes to remote access, right? There are all these different components that need to be configured, and all these different user interfaces exist, such as LDAP console, a certificate console, VPN gateway console, endpoint policy console, software distribution console, and so forth. NCP folds all these back-end user interfaces into one single management console, which really makes it the single point of administration. Or to speak with one of our customers, the headaches are now a thing of the past. Likewise, in a network access control scenario, the management server controls the network access policies and distributes them to the gateway for enforcement. So the entire access is enforced and controlled in tandem between the management server and the VPN gateway. To summarize, the NCP VPN solution is a secure and reliable enterprise scale VPN solution. It's easy to use, scale, and administer. It offers all the relevant components. On the client side, the VPN client with the dialer, the IPsec VPN client, the client firewall. On the gateway side, the hybrid IPsec SSL gateway. And on the backend side, the VPN management offering identity management, network access control, and the high availability functionality with failsafe and load balancing. Of course, in cloud environments for cloud service providers or security service providers, it is extremely important to have multi-tenancy capabilities. NCP has designed multi-tenancy into their products on the gateway and management side. So cloud service providers really can utilize the NCP Enterprise Suite to manage all the different customers and companies from a cloud service environment. And of course, all these different connectivity constellations that exist, right? A user, a company accessing different resources in the cloud, in the data center, from different providers. The software-based approach of NCP that is very scalable and allows for distribution of the various security components in a flexible way addresses actually the scalability of secure remote access out of the cloud in a very significant way. A final word about security automation. I mean, this is really a subject, I would say, probably the advanced subject of this presentation, something that IT administrators increasingly look at. How can I perform security automation? NCP has implemented a version of the IFMAP interface for metadata access point, which is a protocol that actually supports security automation. I just would like to give a brief demonstration of how this could work. Just one example. So let's say a VPN client connects to the VPN gateway. The VPN connection is established, and then the user performs certain access operations that are permitted per the security policy. Then at some point in time, the user may perform some operations that are in violation of the security policy. If those operations are not detected by the perimeter security devices, or such as the firewall, for example, the events may be detected inside the network. If that event is detected, for example, by a leak prevention system, right, that sends a security event to the IFMap server, which alerts the VPN gateway via another security event, and the VPN gateway disconnects the client from the network. So this kind of shows you that really NCP is looking at the leading edge to provide always, the best, security possible, and really include security automation in our enterprise solution. So with that, I just say thank you very much. I'm at the end of my presentation, and if you have any more questions, please feel free to contact me anytime.
Sure. Well, I have a couple questions, Rainer. I'm curious about, as the world seems to be moving to cloud computing more and more, Amazon's trying to be the cloud provider for the enterprise. Do they use is VPN typically used in that kind of scenario where you're doing data processing over the network at some cloud center? Is it used in that kind of scenario as well?
Yeah, I mean, of course, all the access that typically occurs via the cloud, and as you probably know, most of the access control mechanisms are really web-based. All that really typically happens with SSL. So there is, of course, the HTTPS, as the prevalent protocol of managing resources securely, which for the most part is okay, but it's not really traditional VPN, and probably does not really address the security concerns for really high security content.
Yeah. And I wanted to ask you, Rainer, a couple years ago we saw a lot of headlines about VPN related to Firesheep, which was this hacking program, right? So you'd go into Starbucks and someone could basically read what you were doing over the network because there was no encryption involved. Do you know, is that an increasing problem, or has that just gone away?
Oh no, it's not going away. Definitely. I mean, there is the one of the problems, of course, of SSL actually is that man-in-the-middle attacks. SSL is very prone to this kind of attack, and there are a number of exploits that exist particularly for SSL, and there's actually a white paper. I just maybe want to mention that on our website, which is called Debunking the Myths of SSL VPN, which talks in much greater detail about that one slide that I just put up there about SSL security. It only summarizes just a few highlights, but there's much more detail available in that white paper that you can access from our website. So that's a general big problem. There's actually also a problem. To be fair, we also must say there's a problem also in IPsec when you, for example, you go in an internet cafe or wireless hotspot, what you just mentioned, and you try to connect wirelessly. There's a window of opportunity for an attacker to really get in on that connection. And for that, for example, NCP has implemented a hotspot logon functionality that provides opening up the client firewall for only a very short period of time that is just required to initiate the initial connect, which of course provides a potential attacker only a very, very small window of opportunity. So the likelihood of being attacked is reduced tremendously, because as you can appreciate, if somebody wants to hack into something, they typically look for low-hanging fruit, right? And you're really just waiting for a few seconds, for a few second window of an opportunity. Is not typically what these guys go after.
And then kind of a wrap up here, Rainer, I wanted to ask you about, mobile computing. It seems like, I was reading today that tablets are outselling PCs 6-1 or something right now. Are those devices, are they able to be secure and stay secure, or is that a limitation of the platform?
Well, so there are various things that are happening here. So of course, security always is sort of a function of what is it really you want to protect, right? There's certainly a lot of effort right now to secure mobile devices and provide some sort of device identity and device assurance, right? There is, for example, the work that is going on in the Trusting Computing Group around the TPM chip, right? And the Trusted Platform Module. That would ultimately give some assurance of device identity. Then, from a security standpoint, again, I mean, a VPN certainly applies to any platform, right? And you can have VPN clients on any platform, and you can have, you also should have a dynamic device firewall on any platform that works in conjunction with the VPN that really, blocks all incoming connections by default. Unfortunately, there are certain limitations in the platform, unfortunately, because one very unfortunate trend is the consumerization in the mobile device space, where vendors just look at making a quick sell and really look at the consumer mass market rather than what enterprises really require in terms of security. I mean, one example of that is really, if you look at the development of the Android operating system, right, where we only actually got a fully functional VPN API as of Android 4.0, right? Before that really wasn't available, and still Android is lacking a properly API to implement a dynamic client, a firewall, device firewall. So there's still some, a lot of work, I think, that needs to be done in that area. But in general, I mean, people can, obtain high security on devices with a good VPN client or IPsec VPN client. But I mean, there are still other things that are still need to be addressed.
Well, great. Well, Rainer, this has been very interesting, and I want to thank you once again for coming on the show today.
Okay, sure. I'm glad that I could talk to you today, and wish you all the best with your distribution.
All right. Well, hey, thanks again. All right, folks, that's it for the Rich Report. Stay tuned for more news. And